To accumulate 8,000 at the end of 3 years, deposits of 98 are made at the end of each of the first 10 years, and 196 at the end of each of the next 2 years. 1 plus I to the n equals 2. Calculate I. So let's understand these deposits. 8,000 at the end of 3 years is needed as an accumulated amount, and deposits of 98 are made at the end of each of the first n years. So years 1, at the end of year 1, year 2, year 3, up to year n, deposits of 98 are made, because deposits of 98 are made at the end of each of the first n years. So 1 time 1 is the end of the first year, time 2 is the end of the second year, and so on. Time n is the end of the nth year. And then thereafter, for the next 2 years, for each of the next 2 years, deposits of 196 are made. So after this n, the next deposit will be at time n plus 1, 196, 196, and then the remaining 2 years means you go all the way up to the end, because the total time is 3n, and the first n deposits are 98, and the next 2n means the ones from n plus 1 up to 3n. These are 196 each. So the easiest way to do this is to break this second stream of 196 into 98 plus 98. So up to n, we had deposits of 98. And then from there on, we had 98 plus 98. And then the next year also 98 plus 98 all the way up to 3n. And the advantage of doing this is that now we can treat this stream in the bottom row as one single stream of 98 each, and these are 3n payments. And so by equation 15.6, the accumulated value will be each payment 1 plus I power the number of payments, and the number of payments is 3n minus 1 over I. And that's just for the bottom row of 98s, because there are 3n of these payments. And then the top 98s, there are 2n of them, and therefore they will accumulate at time 3n, according to, because they start at time n plus 1, and it's as if they started at 1 and we want to know their value at 2n. It's the same as starting at n plus 1 and we wanting to know their value at 3n. So this time there are 2n of these. So if we call t as the accumulated value of these payments, then they accumulate to 98 times 1 plus I to the 2n minus 1 over I. So same as the above equation, but instead of 3n payments, now we have 2n payments. And remember, the accumulated value is each payment times 1 plus I to the number of payments minus 1 over I. That was the formula which we wrote in 15.6. Actually, it was 25.6 and not 15.6. Was lesson 25 about annuity immediate. And so we want the total accumulated value to be 8,000. The total accumulated value will be this accumulated value of the first stream plus the accumulated value of the second stream, so S plus T, and we want that to be 8,000. And now we substitute this value and this value for the S and T. And we are given that 1 plus I to the N equals 2. So 1 plus I to the N equals 2. So that means 1 plus I to the 3n will be equals to 2 cubed. Similarly, 1 plus I to the 2n would be 2 square. And so we can multiply both sides by I. So the I gets to the right side. And on the left side, when we simplify the 98 times 2 cubed minus 1 plus the 98 times 2 square minus 1, it simplifies to 980. And now we divide both sides by 8,000. So I is 0.1225 or 12.25%. That's choice C.